Hello, I'm Mr. Stevens, and today we're going to learn two different techniques to use for our game show mathematics, okay? So, right now, we're going to work on n choose k, okay? This is going to be number one, okay? So this is how we say it, n choose k, and this is how we write it mathematically. So basically what this is saying is if we have an n amount of objects, okay, we're finding out how many ways this grouping of objects can be grouped, okay? So, say we have 4 objects. So our goal here is, if we have 4 objects, find how many ways we can get a grouping of 2. And with this formula, order does not matter, okay? So, 4 objects, how many ways can we get groupings of 2? Okay, so this would be our n. Our n would be equal to 4, and this would be our k. K is equal to 2 in this certain example, okay? So, the actual mathematical formula for this is n factorial all over k factorial times n minus k factorial. Okay. Let that sink in real quick. So here, since we already have our numbers for our example, we can just kind of plug in stuff. So what I'm going to come over here and do is, so our n is equal to 4, and our k is equal to 2. Okay. Now I'll just start plugging in numbers. So n, which is equal to 4 factorial, all over k factorial times n minus k factorial. Okay. So we actually do the math relating to this, and it turns out to be 4 times 3 times 2 times 1 all over 2 times 1 times, since 4 minus 2 is just 2, that's going to be 2 factorial times 2 factorial. So 2 times 1 times 2 times 1. Okay? Simple enough so far? So, as you can see here, we have 2 times 1 up here, or 2 times 1 down here, we have a 2 times 1 up here. Cool thing about all these fractions and stuff, we can just cancel. So we have a 2 times 1 right here, 2 times 1 right there. That can cancel, that can cancel. So we're left with 4 times 3 all over 2 times 1. Okay, well, we all know what 4 times 3 is. That's just 12. And we all know what 2 times 1 is. It's just 2. Okay? So 4 times 3 is 12. 2 times 1 is 2. And 12 divided by 2 is 6. Okay? So we have 6 different ways to group 4 objects. Okay? When order does not matter. I'm back to give you your second tool in your toolbox in our game show mathematics section, okay? So, this tool is called binomial distribution, okay? And we're given a formula here that will end up giving us a percentage, okay? And that's a probability. So, in this equation, our n is going to stand for our number of trials. Our k is going to stand for how many successes we want to get. And our little p here is going to be equal to the percentage of whatever scenario we're given. So like, if it's flip a coin, it's equally likely to get heads as it is tails. So that's 50%. Okay? Cool? 50, 50, 100. Cool. So, let me give you a scenario to work with here as an example. So say I want to flip a coin 12 times. Okay, so we know how many trials I want. It's 12. So our n is going to be equal to 12. And say in this trial, I want 6 successes. Okay, so I want to be able to get tails 6 times in the 12 times that we flip it. So our k is going to be equal to 6. And just like I said earlier, our p is equal to the probability of our scenario. So since it's flip a coin, that means that it's equally likely to get heads as it is tails. That means I can get heads 50% of the time, so I can get tails 50% of the time. So it's 50%. which is also written as 0.5. Okay. So we plug in our numbers, boom, easy to work with. This super complicated formula becomes really easy, and we know how to do it. So we have 12 over 6. 12 choose 6, 0.5, our k as our exponent, and 1 minus 0.5 with n minus k as our exponent. Okay? So can't really do much until we expand this. And we learned how to do n choose k in our last section. So I'll just do it right here. Okay. And then copy the rest of the problem down. 1 minus 0.5 is just going to be 0.5. Minus 6 is just going to be 6. Okay? And then you plug this into your calculator and you ended up getting a percentage, which I believe is 22.56 in this case. So now you know how to do the binomial distribution.